and the camera is pointing in a weird direction. Let's see if I can fix that. Huh. That's very curious. Well, let's zoom all the way out and I'll fix it as we go. Welcome to a beautiful Saturday afternoon, and I've got a few projects going on, and a very, very exciting new one. It's like, seems to be the case here. Every time I think I better finish one of my existing projects, then I get a whole new one that's super exciting. So I'll tell you about that as we go. Let's focus this thing in and get logged in. Okay, zoom. This. That's a funny angle, isn't it? That is a funny angle. What's up with that? What is up with this camera work? Terrible. Appalling camera work. I should get this stuff sorted before I start, really. Well, there it is. That's better. That's kind of more like what I was looking for. That's a lot more like what I was looking for. So, yeah, let me log in there, and bear with me a second, because there are supposed to be some nice noises that just kind of paused here. And, oh, the noises paused because my job is done. So I have a lasering print job. And so before we go much further, I am going to go take a look at it. And I'll fetch the print over and then we'll take a look at that and see. So hang on just in there. Let me print out the to-do list while I get that. Check that we're online and everything here, and that my to-do list is up to date. I want to look at the head of the to-do list. But if git pull is not working, maybe it's not on the internet. We'll see. Well, let me go fetch my tile. Yeah. All right. Well, that was extraordinarily good timing, because I just ran a cutter on the laser cutter, and it just finished. And it's tile, so I can get away with like walking away from the machine for a few seconds at a time. Although it's still best to keep a close eye on it. And this is the result. Pull that down here. And you can't really see that, let me lay it on top there. So this is the result. It is a subway tile with hearts on it, with a paper tape perforation style. And the difference about this time versus the other times that I've done this is that in this case I've used like a transfer tape to cover the tile. And reasoning there is I still haven't figured out the best way to get color onto the tile. And I've tried Sharpie and I've tried enamels, and I wasn't really happy with the way that the enamels worked out. They were just too hard to use. There's a million little dots in this thing. There's all these teeny weeny little dots, and I want them to get filled with color, and I want nothing else to be filled. So this is a piece of the DEC PDP-11 bootloader, the absolute loader tape, which I cut last time. And so it's marked. I mean, it's a solid enough marking with the enamel paint, but it's really no better than Sharpie. It's no different than Sharpie. I'm not using enamel the way like it could to get real depth. However, my next experiment is to say, let's use this masking tape or marking tape and cut fairly deeply on the laser, and then before I peel the tape off, layer some enamel through it. Because then the enamel will sit in here and stick and dry. And that's the theory. The enamel will stick and dry, and then I'll peel it off. I wonder, can I just like turn the camera around and try doing this? I may as well just do it because I'm in the mood. And I've just finished the project of like the cutting. So let's get down here and actually work on these things. It's like the enamel takes hours to dry. So yeah, I think I'm just going to do it. I'll try one. I'll maybe try one in dark, in matte, then one in gloss. But this seems like a likely enough thing to work. So let's try it. And then we'll get to the very exciting thing that happened this morning. That is actually the main thing I want to cover today. Because it's ridiculously exciting. So let's see. Nice big heavy blobs of enamel. I'm not going to skimp on this stuff. I'm going to lay it in. And basically make sure that all of these little dots here are well filled with good old runny paint. And this time around I cut the dots like twice as hard by doing 2 passes on the laser, because 2 passes on the laser seems like twice as much as it had before. So I can't really tell how deep the dots are, but I'm convinced that they're deeper, and that this is going to give me a way to completely fill them with enamel and then not have it like squish all over the rest of the surface. And I'll get a nice thick enamel coat that'll dry nice and black. And yeah, that's my theory. Then I'll peel off the coating and it'll be wonderful. But we'll see. It'll take 24 hours. I'll post some pictures on Twitter when I've dried it. And it's actually super deep. I can feel like the way it's coming in here, that this is it's really going deep into the cut. So I think there is a chance that this is my successful process. And if this process works, I mean, 3 little hearts, rows of hearts, this is beautiful. I'll mount them on a board and use them as a display for somebody. But if this works, then I'll do like actual programs. The PDP-11 bootloader, the absolute loader, is 18 inches of code and like 20-something inches of header, including the text labels. So that makes for, I don't know how much tile that is, 8 tiles of these 3x6 subway tile. So that's the PDP-11 bootloader. There's a PDP-8 bootloader as well, which is a little shorter, There's a bunch of PDP-11 utilities that are on BitSavers and various other places as paper tape binary images. So let's cut them on tile for posterity and they'll last forever. So, so if you're tuning in and you're mystified, it's a beautiful afternoon, turn off the computer, go outside. If you're tuning in and you're going to hang around, thanks for doing that. I am here at the Brickyard Makerspace in Lynn. Tim was here a little earlier and he's gone home because his print is running. And the main thing I'm going to work on once I've done my little piece of art project is the super exciting thing that brought me in here. And I was even noodling it with it this morning when I got an email, and so I started noodling because I want to get successful at this thing, and it's a subject that I have no knowledge about, and it's an important one in the history of the world of computers, so I'm going to get knowledgeable. And of course the best way to get knowledgeable is to go play. So the system that I'm talking about, can I noodle this and just chatter at the same time? Probably. I feel like I've got the hang of this. It's the enamel is going in really nicely. It's settling into the dots, and I don't think it's going to bleed through the dots because the transfer tape is holding it down. Yeah, well, there's one. We'll leave it an hour and see. I mean, I'll maybe pull it at the end of the shift and see how it gets to. Anyway, there's some hearts on tile on tape. All right. So, before I go to the next one, I'm going to actually show you the thing that I am going to connect to. And the thing is, where's that browser window gone? I'm just going to have to get to Google and try again. They're here. That's what I'm looking at there, but that's not the thing that I'm looking at. The page that I'm looking for is on the Living Computer Museum website. And I can't find the page that I was looking for. Oh well. Let's go browse around and I'll find it eventually. But let me show you what I'm talking about. Because that's much more interesting than watching me chatter away here. So over here on the Living Computers website, there is a whole set of, there we are, that's what I was looking for. The Living Computer Museum, and we've talked about this a little bit, Living Computer Museum in Seattle, Washington, founded by people including Paul Allen, co-founder of Microsoft. And they have amassed a quite extraordinary collection of machines. And they have this kind of thing where they keep them running. And so they have some 80s and 70s PCs and microcomputers, and basically all of the famous names. Some real classic machines, the IBM PC. Some slightly less classic machines, the IBM PC Junior, a flop. The Sun 3 160, kind of my dream desktop or workstation, I guess. etc. Then some emulations, and we'll skip over those. And then some mainframes, some mainframe computers. And these mainframe computers are of interest to me. And we've already connected to the CDC 6500, and I managed to write some BASIC on it that was like the Mandelbrot set fractal. And I was really pleased about how that worked. And the CDC, although it dates from 1967, is still wicked fast. It's like the size of a 386 machine or something like that. But the new one that I just got in the mail is a DEC PDP-10 Access. And I think it's this one. I'm not sure which one of these it is. It's either the slightly old one or the slightly new one, the DEC System 10 or the DEC System 20. And these are really extraordinary machines. So I'm going to connect to the DEC system at the Living Computer Museum if I can. And it's exactly the right vintage to connect from a Teletype computer terminal. Because these things were introduced basically in the very early 70s. I think the DEC System 10 or the PDP-10 was introduced in the late 60s. So PDP-10 may be a bit of a misnomer. Or at least, if you know that the PDP-8 is basically this kind of micro-scale personal computer. It's a 12-bit machine and can have plenty, well, kilobytes, whole kilobytes of core memory. And it got massive use as kind of a lab-scale machine. You can build a rack with a PDP-8 and a set of interfaces to hardware that you want to use, and it was completely versatile, but pretty tiny. A personal machine. An industrial machine in a lot of ways. It's like useful for connecting to control systems. PDP-11 is kind of the classic, I think of as the classic business machine, like the business mini computer before the VAX. Ubiquitous, and a million versions of it. And the PDP-11, of course, is very well known. So you'd kind of think that maybe the PDP-10 was somewhere in between the 8 and the 11, but it's not. It is historically, I mean, in chronology, but it's a very different beast altogether. The PDP-10 is a mainframe from Digital Equipment in Maynard, Massachusetts. And it's a mainframe machine. And unlike IBM mainframes, which are still kind of lots of things about the mainframe architecture are oriented about batch processing and around long-running unattended jobs and around data entry, either a line at a time or quite often a screen at a time. The PDP-10 was designed to be interactive from the get-go, and at the same time it was designed to be a very scalable large machine. And so let me switch to another browser window and see if I've got anything interesting on here. If you look at this little map, this is a map of the ARPANET in, I guess, what's the date on the top of it? Yeah, 1977. So the ARPANET had been around for a few years at this stage, and all the major machines in academia were connected to it. And you can see from the labels that all the yellow ones, like a half of these machines, are PDP-10s. There's some PDP-11s, there's some IBM mainframes, there's a whole bunch of other stuff. And you can see some of the places that they're at. You can see UCLA and Stanford, and on the right, you can't really see it, but there's Harvard and MIT and the Rand Corporation. And so this and some various kind of government agencies and so on. The classic military-industrial complex in full flow here, and all these computers connected to each other. And half of them are PDP-10s. So what are these? Well, they're interactive machines. And I wasn't lucky enough to attend a university that had one running, as far as I know. I mean, I never got to spend time on one in my knowledge. Maybe I did and I just don't remember it, but it's more likely that I just never did. But for the people that did, it was a really super classic important machine. And lots of important pieces of software were written on it. And some of those I want to go play with. All right, I'm still working on this tile thing. 2 out of 3 isn't bad. Let's do the third one. Making a little mess on my scratch mat. So, bear with me while I ramble a little further here. Oh yeah, I better switch. No, that can wait. So one of the interesting things that was written on the PDP-10 is this thing here called Deck War. And I don't know if it exists on the Living Computers machine. I mean, so you can run TOPS-10. You can run basically a PDP-10 in emulation on a PC. You could probably run it on a Raspberry Pi. I haven't tried. But at Living Computer Museum, they have the real thing, actual hardware maintained by people who are going to keep it running. And it's almost 50 years old. And so it's an extraordinary, extraordinary thing to have real machines to connect to. And so I'm going to have, I posted this little poll on Twitter. Do you want, if you have to make the choice, do you want old hardware and new software, or old software and new hardware? Well, yeah. And I think a blend of the two. Do you want old software and old hardware? Well, that's exactly what we're going to get today. If with any luck, we'll have old hardware connected across the internet through some new software, but invisible, to an old machine, old hardware, running old software. And this old software is really interesting, as it turns out. Anyway. I'm still trying to do multiple things at once here, because I'm painting this stuff as we go. But this Deck War was written at the University of Austin, University U Texas at Austin, by people who had far too much time on their hands and wanted to write like a space war game. There's 2 teams. There's the Federation and the Empire. It's a Star Wars, Star Trek oriented game. I'll read the user guide. Actually, I'll bring up the user guide in a second. Maybe I want to print out the user guide on the teletype to keep everything occupied. I mean, that would be a useful thing, because then I'll have a printout of it. Anyway, so yeah, it was originally written, a version of it on a CDC mainframe, and then it was ported to the PDP-10 and expanded vastly, and all sorts of massive features added to it. And basically, you trek through space and have battles, and it's a multi-user interactive game. But it has a command line UI. It's not graphical, because the PDP-10 and the CDC, but especially the PDP-10, I think. I mean, it's like, that is the mainframe that you want to use a teletype to connect to. Deck War assumes that you have a teletype, or something like that. if you look at the deck system getting started guide on the deck system 10, which is a PDF that we can find on this on the Living Computers site, it tells you basically how to log in and stuff. And one of the things it says is, please try to use a hard copy terminal. You're going to find it much more convenient because you can go back and refer to your listing later, unlike a video terminal where things disappear off of the screen and they're gone forever. With a hard copy terminal, you print something out and it's there forever. So absolutely right. These old hard copy machines are useful for something. All right, my painting job is done. Let's sit that back down and leave it there for a little while. So I quite like this doc, actually. I've not read all of it, but the stuff that I have read is fairly straightforward to understand. At least it's wordy in the scheme of these things. And so let's look at it. It says, to begin using the system, you've got to turn the terminal on and press the control key and press the C at the same time. This is called typing a control C. And then you'll see a period, dot, and then type the word login and press return. So then after you see the pound sign, type your project programmer number and press the return key. Well, what is a project programmer number? Turns out I have a user ID and it's like my surname, but actually I'm going to log in with my project number and my programmer number. So I have been assigned, because basically I just mailed off to the people at Living Computers and said, I'd like access to your deck system 10, and they wrote back and said, here you go. So my project and programmer number is like a 30 comma something or other, and then I've got a password, and then you find yourself logged in. So let's go try it. What else are we up to, by the way? I'm just gonna do a check-in here and the chat. Hi, if anyone is in the chat. I don't know if anybody is in the chat because I can't really see. My laptop is too underpowered to really check. So welcome. Let's switch the camera away from my slowly drying tile project, which looks pretty nice, I think. I think it's going to dry good, but we'll see. Let's zoom all of this around and get back into focus. And like that. All right. Okay, well, let's see what we've got. Oh yeah, by the way, there's a chat command, pling GPT-2, that we're going to have this bot work on. We can maybe turn that on later. Did that work? Yeah. Ding. A whole bunch of untracked changes. Well, okay. Oh yeah, there's one there called SSH AWS. So let me. I don't actually know for sure if I'm online here. And the fact that this is taking several seconds makes me worry. And so, I don't think this machine's online. I mean, there is one way to find out, which is like, let's go connect to it. The host, the Raspberry Pi style host that this is running from is called stdio. Yeah, well, that's clear enough. I have a 192 address, I have a 172 address. That's no good. I have a 127 address. That's no use to anybody. Let's just restart it. And if I restart the whole machine, then it'll hopefully boot up and connect to the Wi-Fi, because we've had a few Wi-Fi changes. Still got some to come, I think. But yeah, let's boot the machine. Okay, there it goes. Now, from my other terminal here, let's do a git push and see if that works. And that works. Okay, I'm definitely online now because my git worked. So I can go back here. So I have this SSH AWS that's going to connect me to my Amazon machine. Well, maybe it isn't. Well, okay. In that case, let's go do that from my Mac instead. SSH. Whoops. Wrong window. And is that going to work? That's not going to work. All it's basically supposed to do is like connect me to my AWS IP, and my AWS IP is maybe not set. Well, I better go find out what the IP address of my AWS machine is. There we are. I wonder. I've got a different EC2 public key or private key on my other host. Oh well. So here, this is where I'm going to run this bot, and I'm not going to mess with the bot again today. This is going to run this Twitch bot, and the Twitch bot, I'm running it anyway, just because then if anybody wants to use the !GPT2 command in chat, then there's a chance that the bot will answer it. So anyway, toys. I'm not going to finish that today. I'm just going to leave it there, and we'll take it where it goes. Quick check-in on the tile. My black enamel is looking awesome. It has filled in really well. And if you can see the detail on that at all. Let's see if it autofocuses well enough to see anything. I think you can kind of see some of the detail. These dots are very well filled with black enamel now. And as they dry, I'll have dots with enamel in them. And then I'll peel the tape off. That's my plan. So, yeah, where were we? GPT-2 bot is not doing anything useful at all. It doesn't seem to be responding. Oh, that's because I'm not running the actual bot. There's this web.py. That's the thing here. AWS bot is the actual Twitch bot, and let's see if it. Oh, it's not going to work. All of this AWS Twitch bot thing is not going to work because I invalidated my OAuth. I invalidated my OAuth keys. Okay, let's give up on that. Come back to that next time. Yeah, no bots today. Let's do something far more interesting, which is connect to a mainframe. Now, this may not work, and it may. I mean, we'll see what happens. If it works, it'll be awesome, and if it doesn't, then oh well. So, I got this message in the mail from Living Computers, and they said SSH2 DEC-10 at tty.livingcomputers.org. So let's do it. Living Computers. Aurora. Okay. I'm messing up my buffer all the time. If that font is not large enough, I could zoom in a little bit more. But I think it'll do. Okay, down, up. About there. Do I want to do this? Yes. Aha, permanently added. Great, exactly what I want. Now, let's see if it actually finds the machine. Yes, at least the SSH gateway is up and running, so that's a good sign. Some escape characters that clear the screen or something. Okay, now my PPN. And then my test. And I'm in. And I'm in. I am actually connected to the PDP-10 mainframe at the Living Computers in Seattle. And it says, please note that closing a terminal window or program does not log off. You've got to actually use the kjob command at the dot prompt to actually log out of the system. Okay, so that's great. This is not Unix. This is TOPS-10. It's a DEC System 10. So let's have a look at who is on and what the machine is doing. And this could be a long listing, but systat will tell me a bunch of stuff about the machine. And let's watch it as it goes. It's actually not very busy. It's been up for a long time and it is not heavily used. But if I can find other users online that we can do deck war interactively, then that would be cool. I think there may be tab characters that aren't getting interpreted as spaces along here. It seems like the print head is jumping around a little bit more than it should. Like there's some extra characters in there. So this is hard to read. It should be in nice columns. But anyway, good enough. Yeah, so that line that says brackets self says that me, my login, I'm running systat. And then there's a bunch of other people or other sessions running other things. And two of them are 30 comma something, which I guess is like interactive users like me. I may need to do something special about resolving tabs to spaces to get this to lay out nicely. But we'll deal with that. So, we had 2% of swap used. And we had 6623p of core left. Now, I don't know how much memory this machine has, and I really don't know how to interpret that. It's a 36-bit word, but I don't know if that means 6623 pages, like 1K pages, if it's like megabytes of core. Yeah. Oh, and there's a section here called high segments that you can see on the printout. There's a piece that says high segments something or other, and this is a pointer to the little that I know about deck war. So on the Unix systems at the VCF East, we had a lot of fun having one terminal logged in and another terminal logged into the same machine, and using the write command to, like a chat. And write is super simple. Basically, it doesn't really have any shared anything. It just, you type a message on a terminal, and it sends that text to the terminal directly, to the device of the terminal, /dev/tty whatever of the other user. I mean, essentially, there's a little more to it than that, but that's the shortcut version. Write doesn't really have any shared anything. But Deck War does. It's a real-time interactive multiplayer game. And so what are you going to do to send state from one player to another? Well, it turns out on the PDP-10 you can share memory across processes. You can assign some high memory segments and say that they're shared, and then a bunch of different users can read and write them. So that's the basic architecture of DECWAR at the totally superficial level that I understand, which is you'll have a process running for each user, and they'll share high memory, which is the game state. So it's not a networked game. It's a multi-user on the same machine game. There's no need to be a network if you've got a mainframe, right? You don't need like TCP/IP because everybody's on the same machine, but you've still got this multi-processing going on. So let's switch back here to the DEC system doc so that I can figure out what I'm going to do. It says saying goodbye. To log out, what you do is you press K/F and press return, and then it logs you out. K, I assume, is like kill job or something like that, and F is flush all the files so that it closes them. So the /F is like a in Unix you'd have command -something option. In this you'd have /F. Now, typing an easy command, I can do this one. It says daytime. Let's try it. I could do that's my level of difficulty right now. Yeah. Okay, I timed out. Let's go read the manual a bit more and figure out what we're going to do when we connect next time. I've done systat to figure out what's on here. There is extensive doc, but I think the fact that it is very extensive. I think what I want to try do is basic. And so one thing that I should be able to do is to write a basic program to write a Mandelbrot set in exactly the way that we did before on the CDC. So I think that's maybe something to try. Unfortunately, my browser slows down to treacle when I'm running OBS to stream stuff. So actually reading the doc, it's going to have to happen offline. But let's see if I can't scan and find a little bit. Yeah, here's the initial section of the manual. It says, if you want to use basic, going to the divider labeled using basic, because this is using the SOS editor, using RSOS to run the SOS editor to edit a file and then compile it for Fortran or for COBOL or Algol or whatever else you're going to use. Bliss, I think, is the system language that we might want to learn a little bit about to actually do useful things on this thing. So I'm going to scroll away further in this file and see if I can't find how to use BASIC. Well, getting help from TOPS-10, that's great. One thing I learned in my little bit of browsing today is TOPS-10 has a file name structure that is kind of like the inspiration for MS-DOS. Files have extensions, which are 3 characters. Now, direct, there we should learn how to do that. Direct is to list your files in your user area. It's known as your directory, and it's identified by your project and programmer number. So yeah, we can look at the directory. I didn't read the doc about how to use the editor, so I'm a bit wary of getting into an editor I can't get out of. But now let's look at using BASIC to see if we can do that. To enter your program, you say R BASIC, and that'll run BASIC. And then when you see new file name, oh yeah, you just say new and give it a new file name. Okay. So let's try this. I'm back at the Unix prompt, and I have a Mandelbrot set program for various kinds of machines. I forget exactly where. Yeah. So here's my Mandelbrot BASIC files. So I'm going to print one of these to paper tape because I can't copy and paste from the clipboard onto the DEC System 10. And so I'm going to do this old school, the old school way of transferring a small computer program from one place to another, is to punch it on tape. So, that didn't really do what I expected. Okay, so yeah, I want to turn off some of the built-in TTY stuff, but this echo business is all wrong. So it shouldn't say echo, it should say print, or printf, because echo turns that \033 into, like, it doesn't actually print the escape sequence. So meanwhile, right, before I want to punch a tape, I want to turn off in the firmware that I'm running to connect to the teletype. I want to turn off all the anti-escape characters. And so I have some escape sequences that my thing will respond to. So let's edit that. Wow, what is going on? Wow, I'm stuck in the editor. I'm stuck in the editor for weird reasons, which is very unusual. I think maybe my my terminal settings are slightly messed up because of trying to do too much. Alright, bear with me a second. I am gonna kill this and do it from back here. 4737. There we are. ASR33 bin, and I'll use VI. Down at the bottom of here, No, there we are. Let's okay, that's better. Okay. Now, much better. Now my terminal is in raw mode, and that means it's safe to punch tape. So, but as you can see, it's in raw mode. I'm not getting carriage return to line feed conversion. I hit carriage return, the Unix shell interprets it as a new line, but I'm not getting echoed a line feed. So this kind of proves that I'm in raw mode, which is, I do want to be in this funny mode. I just want to take that Mandelbrot bat basic file from the MISC directory and cat it, but I'll turn the tape punch on when I do. Alright, let's try it. A little bit more nulls. More nulls from the here is key, because that just sends nulls. Yeah, let's see. Okay. It's going to punch against the end of the line because I don't have any carriage returns going on. But out here, it's punching tape very happily. So this is the Mandelbrot set basic program, and it's, I don't know how many lines of basic, 25 or 30. So when I've printed this, then I can log into the Deck System 10, and my session is probably going to be all back in because I didn't use kjob to exit it. So oh well. Yeah, then I should be able to load this tape in. We'll see. Chances of it actually loading are slim. There's one thing that I've tried loading tape before and I'm worried is still a bug, which is on my firmware, when I, like the serial driver for the Teletype is a piece of slightly custom Arduino code that I hacked around from somebody else's code, as is my usual style. And so the chances that it has bugs is enormously high. And I think there's a timing issue that if I load too much stuff from paper tape and it tries to echo at the same time, like full duplex stuff will freeze the Arduino machine. And then my terminal will just stop. So we're going to run that risk. But I think it's a risk worth running in the service of retrocompute. So yeah. Now, I have paper tape. And there it is. Turn that thing off. And in the style of retrocomputing, I'd better label this as Mandelbrot. So that's the documentation for the archive. All right. So there's my 25 lines of basic, and very convenient small amount of tape. Let's go back reset the timer. Oh, you know what? Yeah, it reset itself by now. We're good. We're back in sane STTY land. So, back in sane STTY land, I can consider going back online to the deck system. I've got a basic program on tape, just here. I'm going to roll it up. Unfortunately, I don't have like a tape roller, so you're going to do this the slow way. Highly valuable manual set program. It's open source. Feel free to copy it. And maybe I should print this on tile and stick it on the wall. There is a Manbo set basic thing. SSA. The living computer using it. Okay. Let's see if I can remember how to log in again. And then I'm going to use the directory command, and then I'm going to go into basic. Oh. I'm already logged in. Okay. I hope you didn't see my whole password there. And it's a weird thing, this logging off job thing. I think I just logged somebody else's job off, and they might be mad at me, so I have to just apologize to them. Madej or Maid J. If that was you, I'm sorry, I'm a newbie here. I owe you one. All right. All right. My directory is empty. That's okay, I think. For help, type help. I could do that. Yeah. I hope it's not too long. It says 2 pages, and a page is presumably like 24 lines or something. Luckily, this wraps at exactly the right place for a teletype, and I think that's no accident. It's designed to work really well with a teletype. Okay. And so, because this is like a different OS, you have to just forget everything you ever knew about Unix. Devices do not necessarily mean the same thing here. VTA4, I assume, is a disk, but I'm going to have to go learn. And if anybody who knows TOPS-10 is actually like watching this, then tell me. Help me out here. Alright, so in BASIC, this is what I was hoping for. There's kind of a built-in editor that knows about line numbering. In the same way that we've seen with the HP2000 and with the CDC BASIC editor. But once you're in BASIC, lines number themselves, or keep themselves in sequence. Like the line number is way more explicit than like a Unix file where you just have like a line break and no explicit line naming. BASIC at least has this concept of the naming is built right in. So we can take programs in core and create new ones and give them file names and erase them from core. So I can also list it on the line printer, not on the terminal. And that would be handy if I was near the line printer. I assume there's a line printer in Seattle, but that's the other side of the country. I like the unsave flag, that sounds useful. And so you can see some of this kind of TOPS-10 format of like a command and then flags, /flags. And those slash flags then kind of inherited their way into DOS, I think, by my understanding. And so that's why DOS has slashes instead of dashes for most of its kind of option commands. So we can replace a file, or we can save it, or we can scratch it. And then we can exit from BASIC that we're in right now, back up to monitor level, which is like where I ended up. It's the place you come to when you log in, from where you can run other programs, subsystems. So you can unsave files. That's kind of interesting. And the file name is up to 6 characters. And then the extension is 3. So file name dot extension. Oh, this seems pretty accessible, actually, fairly usable. So this was very end of the 60s or into the mid-70s. And so it's not surprising that it's pretty user-friendly. It's also a deck system and had a lot of users. And so the whole system is pretty highly evolved. And yeah, I think it's going to be easy to use and fun, and we should be able to be productive with it. I hope I'll be able to load this program from paper tape. Oh yeah, excuse the overprint at the beginning of the line. I don't have enough delay on the character term, and it's slightly over damped on the physical carriage, so it doesn't get right back to the beginning of the line before it prints again. So it's really interesting. This doc, I think, is being formatted on the fly for 72 characters a line. My guess. I think it's like. I don't think this is just a text file. It's a formatted text file because it's right justified. It's fully justified. So I don't know what kind of runoff style text formatter they've got going in here, but it's doing the job well. It's wrapping exactly where it should. Okay. Well, that kind of sucks. My network connection failed, and that really sucks because it only failed because I wasn't. I think if I'd been busy on it instead of just waiting for the printout, then it wouldn't have failed. But that kind of sucks. I wonder if there is a timeout. There is a connection timeout on SSH. But I don't think there's like a idle timeout that I can control. Oh, I have other jobs in the same PCA. So I have 3 sessions going on here, and I'd better figure out what they are, because I've got K jobs on 15 and 16 and 17. Yeah, so I do need to know this stuff, but what I'm looking for is how do I kill another job if I've got these 2 other jobs open. I'm not sure exactly how to do that. So let's do the job. Okay. This help file may be more verbose than I was expecting, but I guess that's good. Yeah. Okay. So I do want the disconnect, the kjob/disconnect. But what I want to do is kill job 15 and 16, so that I don't like end up using all the jobs. So yeah, let's see. In the operator manual, I can't find a searchable one yet, but kjob is on line 2125 of the doc. And I think the kjob command help is pretty much exactly the same as the stuff that's getting printed out to the terminal. Okay. All right. Well, that was great, but not really as useful as I was hoping for. I may have to read all 300 pages of the doc to get further, or at least skim them. Oops, glitching. All right, we are. Sorry about all the networky glitches. I'm having some Wi-Fi glitch here as we go. All right. Yeah. Well, okay. So I have these other jobs and I don't know how to kill them or how to like terminate them. If I log myself off just here. So I'm I'm not logged in. I'm at the login prompt. And I wonder if I can like reattach to my other job. So, yeah, that didn't get me to where I wanted to be. So I can relog into this thing, and that would be great. But I'm not sure how to like reuse or clear up these previous jobs that I had logged in for. Okay. Well, sorry for all the very, very flaky networking stuff. I've got glitches all over here. And, yeah. I have jobs 15 and 16. And if I log in again, it'll give me job number 17. And I guess I still think I don't want that. I think I want to figure out how to reattach. Now, reading in the manual here, at the beginning of the manual it says Control T. When you type Control T, it'll print status pertaining to your job. I guess that's just like CPU usage. That's not really useful enough. Okay, so there's a few control characters we can print that do things that might be useful. And there's a whole section of the manual that talks about these device names that it was that it mentioned in the save in the basic instructions. You can talk directly to a card punch or to terminal readers and so on. So this is kind of cool. But let's switch back to the screen and see what it's saying. I can do login/attach:\ask. I can try it. Yeah, and we've got a lot of help to get through here. And this is just the help for the login command. I'm not even logged in yet, which I think is kind of friendly for the OS to give me all the help. However verbose it ends up being. All right. I don't think I'm going to really succeed at this today. Now, so what I'm seeing here is like ridiculous flaky networking stuff. So with that level of stability or instability, I guess it's not too much fun to follow along. It's going to be ridiculously jumpy. So when this finishes, I'm going to let it run. But when this finishes, I won't try to do all of the basic work that I was thinking of. Instead, I'm going to switch back to my enamel painting and see what progress we have there on my experimental enamels. Alright, this is a super helpful mainframe. And just as a reminder, this is connected to, not yet logged into, but connected to the DEC System 10 at the Living Computer Museum in Seattle. And it's an original mainframe. It's not a synthetic, like, simulation. It's the real deal. We're connected to a mainframe. And the mainframe dates to the early 70s. So this is a lovely and wonderful and slightly unique retrocomputing experience. And it's the real deal. The Teletype is the classic terminal for this kind of thing. So like late 60s, early 70s vintage. And it is a 33 ASR. In Russian, yeah, using Cyrillic, it would be the ASR in Cyrillic, exactly. So this is a Teletype 33 connected across the network to, hello Ant1, Fritz1, yeah, connected to a DEC System 10 at Living Computer Museum. And just to give you a little reminding taster of the machine we're connected to is, I think it's this KL10. I think it's this physical machine that you can't quite see in the page. Yeah, it's the DEC System 10. And here there's the user documentation, and I have not read all of this documentation. Oh, sorry, yeah, it's the DEC System 2065. So I've not read all the doc, and so we're printing out a little bit too much of it onto the... Yeah, we're printing a lot of it onto the terminal. I have one viewer, and this is me, and this is awesome. Thank you. And I guess you're Russian, just judging by the text that you're writing that I don't understand. Welcome. So yeah, this is a 33 ASR. I'm in Massachusetts at a makerspace called the Brickyard, which is in Lynn, Massachusetts. And I'm connected to a mainframe from the early 70s in Seattle. This machine runs, this machine is a computer terminal dating to 1969. And what I'm actually doing right now is just, let me show you. Way back here, I said, help, log in. And so I have 2 pages of login help. Yeah. So I want to get to writing BASIC. I have to wait until the help is done. So yeah, it's super close. Yeah, let's see what I get. Oh my goodness. Oh my goodness. It is going to be a long, long help file. Like really long. Because it's now listing all of the option codes for the login. For the terminal type. Like in Unix, STTY can change the terminal type. And then the term info and so on. But at this you can specify it at the login prompt. And it's ridiculously loads of millions of options. So yeah, we could close it and let it just type and come back and read it later. I think I'm going to let it run in case it's interesting to watch. And I have the printout, so I don't need to watch it run. The other thing that I'm doing in the meantime is this, which is printing paper tape patterns on subway tile. And here's some that I enameled earlier, which are little hearts. They're not very well dried yet. In fact, they're still very, very sticky and soggy. Oh no, they're less sticky and soggy than I thought. I'm going to peel it. So let's, beautiful. And it needs to have longer to wait. Let's drop this here. So there, it's beautiful tile. So this is laser cut tile. And my plan to use enamel paint on this worked. It just worked. So now I have a result. I can laser cut paper tape patterns on subway tile. And it doesn't look perfect. I'll have to redo this exact one. If you can see some of the detail, there's a little bit of material on the surface. It doesn't quite work out right. But then, if I can do that, then I can punch, actual tape on tile. And instead of ending up with something like this where I don't know how to fill in the dots, this is the PDP-11 bootloader. But I can print the PDP-11 loader onto tile and have it come out beautifully. So I have a production process. So now I know how to do tile, and I'm very, very pleased with that. So yeah, I'm assembling this whole set of interesting things that you can do with a Teletype. The other interesting things are emoji, and on my Etsy you've got some emoji. So I'm very, very pleased with this process. All right. Yeah, it's still printing. And this is just the help for the login command. Sorry it's so slow, folks. I want to get to actually productive writing programs that work. I'm not going to get there today. Oh well. So yeah, let's look at that. Did that work adequately? It did. Yes, that's good. Alright, where's my tile? I've got a bunch more of these subway tile that I'm going to print. So I'm preparing some subway tile while this thing does its duty. And yeah, I'm going to print lots and lots and lots of subway tile. So while this is printing, I guess I'll show you the process of this tile. And these things come with a bit of chalk on them. I'll scrape that off. And then I'm going to stick some, this is like vinyl wrap, and I'll put some wrap over them. And then once they're wrapped, then I can laser cut them using my laser cutter, and then I can enamel on the surface, and it'll come out good. So that's my plan. Let's zoom back in here, see what it's doing. We're up to the examples stage. we're up to the examples. Okay. Hey! Oh wow. Right. Let's connect back onto the machine. Where's my password? Now, I want to say login / attach :ASCII. Okay. No. Maybe the attach command is going to do what I want it to do. I better look it up in the manual because this is so slow. Well, I guess let's go to basic. Am I still going to do this? Sure. Oh, yeah. It's not basic. Run basic. Okay. So where's my Mansbro set? Here's the tape. Let's zoom out so you can see what I'm doing here. What I'm going to do is try and load up the tape in here and then hit run. Now this might fail disgracefully, but I'm going to try it anyway. So if I load up the tape here and hit start, okay, come on then. I think that works. Okay, that's fine. So it's I thought it was completely broken. I thought it was completely broken because that long line of garbage there. But that long line of garbage is actually deliberate. So let's keep going. Wow. You know? I think we loaded a basic program from paper tape. And line 130 is busted. That's where I stopped. Make that font a bit bigger. Yeah, line 130 is busted, but I can fix that. It loaded the whole thing perfectly. And my tape had like line feeds without carriage returns because it was a Unix tape. But the system just handled it. So we have copied and pasted onto our mainframe using punchtape, the original archival storage medium. So I guess I should print this punchtape onto some tiles. It's wonderful. It's like a real program. If you want this, by the way, you can just go to my ASCII store and for $5 it's yours. All right. Now, 130 dim $7. Wow. What do you think? Is it going to run? Oh, we got a mod. Is this an interactive BASIC? I think it is. I don't think it's just like the BASIC editor. Normally, if it's BASIC, I don't have the manual up on the thing. No. So this mod thing I need to go look at the basic reference manual to see how to do modulo arithmetic. And on the CDC, I had to actually kind of fake it because the CDC didn't have modulo arithmetic either. So I wonder if I can bring up the listing of where that was, because well, let's share this browser and you can see it. This is the version for the HP 2000, and oh, I didn't have any modulo stuff here. Slightly older version. On the Prime, oh, again, I had a slightly older version. It was this one here where I was doing like modulo stuff, and let's look on the CDC version, because I'm fairly sure I did this in the CDC. Yeah, but then that's the same, effectively the same as modulo, the mod arithmetic that I have on this thing. 470, yeah.